Okay, length of another curve. We did a length of a curve last time, so let's do length of another curve. Okay, we know that by now we need the derivative squared, so let's find, it would be dx dy in this case. So dx dy, it's a little backwards looking, but it's cool. Okay, y over 3, and then this will just be 1/2 minus 1 over 2 square root of y. That's not a problem, we know how to do that. Right there, so what's that going to leave us with? Square root of y over 2 minus 1 over 2 square root of y. Almost root of 2. Let's see, let's get some common denominator action going. Okay, and, well hell, this is pretty easy. Dx dy is just going to be equal to y minus 1 over 2 square root of y. Okay, and for our formula, we need this to be squared. So let's just, let's see if there's anything we can do to kind of mess with that. Okay, so let's plug our length in here. So let's see here, length, is it on the page? No. Alright. Now it's on the page. Now I'm looking for 1 plus square root of the derivative. So that's, or not the square root, but the square of the derivative. Okay, I got that. There's dy. Actually, dy is not included in the radical. Sorry. Okay, so let's see here. What are we going to do? U substitution maybe? Minus 1, so du would equal just 1 dy, so ooh, that's not going to work. Okay, so let's see if we can rewrite it as a square, and I'll have to do that on the other page. While I'm doing that, I want you to stare at it. I want you to give it like the 500-yard stare and see if there's anything that you can do to maybe make this a little better. Here's what I'm going to do. I'm going to expand this whole thing, okay? So it's going to be plus y squared Alright, don't worry, I'm putting it on the paper. Okay, there we go. Okay, all I did is I just squared this whole thing. Okay, I got y minus 1 times y minus 1. I expanded it right there using the FOIL method, and then the bottom term I just squared it too. So it looks like, let me see here. I'm shuffling papers around again. Okay, what I'm gonna do is we're gonna try and see if we can combine this 1 in here somehow, and I think the best way to do that is just to call it a 4y over 4y. Okay, and now if we, let's not pay attention to the radical for now. Let's just look at the inside of this thing. What's this? This thing going to be 4y plus y squared minus 2y plus 1 over 4y, isn't it? Okay, so this will actually, this will simplify to y squared plus 2y plus 1 over 4y right there. And you know what? Actually, I can see it already. This will be y plus 1 so that gives us our square right there. Okay, so actually this, we're not going to do the equal, so the length is going to be equal to 1 to 25 of the square root of y plus 1 over 2 square root y squared dy. Does everyone see how I did that? Okay, I started right here with this thing, and the u substitution didn't work, so I just expanded, I rewrote this. This thing right here is just y minus 1 squared over 2y squared. Well, I just expanded that, and I ended up with this polynomial here. And the trick was I wanted to throw this 1 in here somehow. So I did that, got the common denominator in the process, and I ended up with this guy right here. And then I turned him into this guy because I had the like terms, the two y's, okay? And then fortunately I was able to factor this out and I was able to get a square. So now we have that situation where the radical and the square cancel each other out. Okay, so my length is equal to the integral, let's see, y plus 1 over 2 square root of y dy. Okay, so this one, I'm looking for paper now. Okay, so let's see, this is also equal to 1. Let's see, this is, actually, you know what, I'm going to yank this 1/2 out. So let's see here, let's take the 1/2 and yank it out. So L is equal to 1/2, 25. And then I'll be left with y plus 1 over square root y, which I can easily break up into fractions. Okay, so I got that. And we're going to do some more simplification. Wow, this one's taking a long time. Hope you guys aren't getting bored. Okay, so this now we'll just simplify this. This is just y to the 1/2 plus y to the negative 1/2. See, I'm just doing algebra right here. I'm just simplifying this down and getting that term by term guy that I like. And let's see this. Do I need another color? Maybe. So let's see this. This will be equal to 1/2. Let's see here. Wait, no. No, I'm sorry. That is 3/2 minus sorry. I had a brain malfunction there for a minute. Oh god, okay. Forgot what I was doing. Okay, here we go. The 2's look like they'll cancel out no matter what. So we're left with, it's hard just keeping track of all these papers. They're everywhere. Okay, so I got y to the 3/2 over 3 minus y to the 1/2, 25. There we go. So now I'm ending up with 25 to the 3/2 over 3 minus, this is just going to be 5 minus 1 minus 1, 1/3 minus 1. Alright, okay. So here we are, we're right there. 25, square root of 25, that's 5 raised to the 3rd power, that's 125 thirds minus 5. 1/3 minus 1, that's negative 2/3. Okay, so we're gonna have to get some 3's going on in here. So that's 110 thirds plus 2/3. That's 112 thirds, and that should go in there. 100 divided by 3. Oh crap! Get the calculator. It doesn't go in evenly, I'll tell you that. So Wow, we finally got it right there.